Hey, thanks very much for having me out at JokerConf. I've heard a lot about this conference. I've been with the Java community for a long time, and this is my first chance to attend and see the conference in person. And another great thing about my trip out here is this is my first big conference presentation as a Java champion again. So So after I left Oracle, I got reinstated as a Java champion. What I'm going to talk about today is different technology hype. So I've been on program committees for a bunch of different conferences, Java One, Devox, helped out with different conferences around the world. And you see a lot of the same technologies coming up. And the first question you ask yourself is, does this matter for me? Does it matter for the type of development that I'm doing? Is it something which is relevant to my job, to my field? And you don't always have time to research it fully before you jump and dive into a new technology. And sometimes it works great, and then sometimes it's not. So we're going to go through a whole bunch of technologies in a very short period of time. But before that, I want to show you guys a short video. And this is actually kind of a making of for the presentation. So this presentation was actually ridden on motorcycle. The various parts of the presentation you're going to see, we did communicated via radio. So Sebastian Dashner, who you guys have seen at the conference here and is one of the organizers of JokerConf, myself and other Java luminaries were going around Japan via motorcycle. We would discuss different technologies and what our opinions of them were. Put together some slides to describe it to the user groups, and then present a different one of these technologies at each of the user groups. So things like Bitcoin, or blockchain rather, chatbots, serverless, containers, DevOps, and machine learning and AI. And each of the sections was actually written on the way to a different city. And this gives you a broad range of different technologies which you guys can experience today. So does anyone here in the audience, are they a expert in all 6 of these? There has to be somebody here who's really good. Okay, I'm sure you guys are just shy. But this is one of the challenges with technologies, is you hear about things in tech journals and news, and you don't get a chance to research them fully. Like, for example, Bitcoin. So this is not blockchain, right? But blockchain is one of the fundamental technologies which contributes to Bitcoin implementation, and it's a great use case for blockchain technology. And Bitcoin is also had a huge run in terms of the value of Bitcoin. Does anyone have any Bitcoin in the audience? Okay, so a few brave souls. Watch your digital wallets on your way out, because you might get mugged for beer. At the peak, blockchain got up to one Bitcoin being worth 20,000 US dollars. So that's huge for a digital currency which intrinsically has no worth, right? It's not backed by gold. It's not backed by a government. It's simply a currency of exchange. So the real value of Bitcoin is exactly that it's a universal currency. You can divide it down, use it for transactions. It's not tying you to a specific country. You can cross borders with it. So it allows you to do a lot of types of transactions which just aren't possible with other monetary currencies. One of the disadvantages of Bitcoin, though, well, actually, getting back to beer. So if you're going to buy some beer for friends, A great place to do it with your Bitcoins would be in a place like this. So this is one of our initial night hacking broadcasts that we did in Java conference. And you can see this was the Java 8 launch party. Everyone had beers, which is essential for a good broadcast. And then we had some Oracle people in the corner who were, giving the official announcement while we kind of heckled and talked about our opinions on the Java 8 release. So this was a while ago. Who's using Java 8 in the audience? Oh wow, that's a lot of hands. Okay, so we haven't gotten that far away from Java 8. And actually, Baruch and I did some interviews and exactly talked about this, the migration path to Java 11 and to future releases. So getting back to Bitcoin, one of the things which is the challenges with Bitcoin as a currency is the energy consumption of Bitcoin. And if you look at the energy consumption over time, it's grown exponentially because the amount of energy which is consumed by Bitcoin mining, so Bitcoin mining is the process by which Bitcoins get created, but also it serves as a network that does reconciliation for the network. So when you have a new transaction coming in the network, it's group consensus of miners, which determines the next block in the blockchain. And the problem is that the value of mining is directly proportional to the value of Bitcoin. So at its peak, when Bitcoin was at its hype, there was 75 terawatt per hour's consumption used by just Bitcoin mining, which is huge. And you can see even though Bitcoin hasn't returned to its previous high, the mining has. So all those miners have turned their servers back on, and they're mining just as much as they were before. And we're consuming a huge amount of energy for this. Another way of looking at this is the amount of energy consumed by US households. So the Bitcoin energy consumption is almost 7 million US households. Ethereum, which is more energy conservative, and actually they have a new algorithm which should significantly reduce the amount of energy consumption by Ethereum, about 1 million US households. You may not know this, but does anyone have a good old-fashioned credit card in their wallet? Okay, so you guys are all conservationists. You're saving the planet by reducing energy consumption, so good job. Visa actually is comparatively extremely efficient from an energy consumption standpoint, just because it uses, it doesn't have the mining proof of work, it doesn't have all that, but it has other disadvantages. It's basically you're relying on a backing agency to do all the transactions. It's also currently about the same energy consumption as this country. Does anyone know what country this is? Just shout it out. Okay, I heard it, Venezuela. So all the people in Venezuela use the same energy currently as Ethereum plus Bitcoin added together. So this is a huge waste of energy. But really, the goal here is not to talk about Bitcoin. It's to talk about blockchain. And blockchain as an underlying technology behind Bitcoin is actually really useful for a whole bunch of other industries. So the basic way which blockchain works is you have a bunch of different transactions which you're trying to execute on the network. They get hashed together using a Merkle tree, so you hash them and you hash them and you rehash them and you get final hash value. You hash that together with the previous block's hash, with a timestamp and with the nonce, and this becomes one of the candidate blocks to be added to the blockchain. And the way you determine what the next valid block in the blockchain is by consensus on the network, or in the case of Bitcoin, it's by majority of miners. So you do an algorithm where you try to figure out what the next block is. This obviously introduces some challenges if you want to do more of an enterprise usage of blockchain. So on the left side are the characteristics of public blockchain. So that's what Bitcoin and Ethereum for use of digital currencies are. On the right side are examples of private blockchain. And one of the characteristics of these large public blockchains is that they typically require a large peer network. You're doing reconciliation by the majority of miners. You have extremely long transaction times. Bitcoin has 7 transactions per second and takes 10 minutes just to complete one transaction. So That's probably not something you want to wait for if you're designing a system for health services or financial or other applications. Ethereum's faster, but still it takes quite a while. So it's 15-second completion and 15 transactions per second. You're also limited to the amount of data you can put inside the transactions. For Bitcoin, this was somewhat controversial when in a couple check-ins, the founder actually checked in a hard limit of 1 megabyte for the Bitcoin transaction size. So Satoshi did that. On Ethereum's case, it's limited by gas, and you can check the current gas limits. When I checked a couple weeks ago, it was almost 10 million gas was the gas limit. And this is basically a way of separating out like the cost of transactions on the network. So you're paying for usage of the network, but not directly tying it to the currency price, which would make it challenging. So you can use gas to execute things on the network like smart contracts. And this allows you to execute different algorithms on the network. In the case of private networks, you have a lot more control. So you can invite people to the network. You can reconcile by consensus or other algorithms of your choice. You can have much shorter transaction times for the amount of time you want things to complete on the network. Unlimited data, you can do a lot more with smart contracts. And of course, the biggest thing probably is privacy. If you have a business use case, you often don't want all of the transactions on the network open to everybody in the network. You want to be able to control who can see the actual transactions. There's a couple possible implementations which you might be using for this. One would be Hyperledger Fabric, which is an Apache project. It does mining proof of work or consensus by a pluggable implementation. You can also do smart contracts in Go or JavaScript. You can also do Java or a whole bunch of other languages by plugging in modules into it, and even do Ethereum smart contracts with using Sawtooth. And this allows you to use Solidity, which is the language for doing smart contracts in Ethereum. R3 Corda is really designed more for the financial industry. It was open sourced. It allows you transaction level with notary nodes, smart contracts in Java or Kotlin, not designed to be used as a cryptocurrency. And increasingly, folks are using the Ethereum private implementation to do blockchain and network. So you can do your consensus, use smart contracts in Solidity, and then it also has, of course, a built-in cryptocurrency because that was the original use case. So here are some of the industries which you might find yourself using blockchain for. Maybe financial services, medical and healthcare, IoT, legal. Anybody in any of these industries in the audience? OK, a couple folks. There's one other use case which you might want to use it for. So this is a supply chain use case. And here's a short video talking about this.
So this is one of the first batches of beer that we actually produce off of the tanks that are equipped with the sensors.
If we could track in one program or one data set the farmer, the field, when it was harvested, those field conditions, whether it was there was lodging of the barley or whether, what the temperature was that it was harvested at, even things like what nitrogen he put in the soil.
People are interested to know a little bit more the story of what went into this beer.
OK, so this small brewery, Alpha Acid, they're literally down the street from my house. So they're in the same town as me. The owner there on the right, Kyle Bozovic, he has a small brewery, and I helped him instrument all of his fermentation tanks. And the other with pressure, temperature sensors, all sending data to the cloud. And the other thing we did is we also went to his suppliers. So for beer, the basic ingredients are hops, malt, and yeast. And so we found a local yeast provider, a local hops provider. Actually, hops are mostly gone from the Bay Area because of prohibition. but they're starting a resurgence as people get more interested in kind of boutique products and knowing about what's going in their beer. And what we enabled was the beer has a small QR code on it. You can scan the QR code, and it will actually pull from the blockchain transaction ledger information about how the beer was produced from the upstream suppliers who are also participants in the blockchain. So this is all great. A few folks raised their hand on industries which are actually doing stuff which is relevant for blockchain. For everyone else in the audience, you're probably better off with one of these. Just storing stuff in a database meets a lot of the requirements for what you need to accomplish, and often blockchain is overkill for a lot of applications. All right, so next we're going to chat a little bit about chatbots. Chatbots, you probably think of, maybe a little cute little robot like this, or perhaps a robot bartender. There's some cute videos on futurestates.tv which highlight different futuristic scenarios. This is one of them, but realistically, you're probably going to be doing something more like a traditional messenger. So, Facebook Messenger, WeChat, Slack, and then doing some interaction where you try to enable conversations. So some examples of conversations which you might enable via chatbots. So maybe sending roses, so buying roses for your girlfriends, booking flights, doing grocery shopping. And these are all quite reasonable conversations. You might want to have to do operations on your phone, or even be talking to a voice-based system. Hopefully, your chatbot conversations are slightly better than this. And really, what you're trying to do when you build chatbot user interfaces is you're trying to guess what the user is going to say with certain keywords, use some intelligent processing, maybe machine learning algorithms to guess what they're trying to say, and then present them with a choice which is close to what they would want. Often your chatbot user interface is not even a phone anymore. It's some sort of audible interface, like Google Assistant, Amazon Alexa, HomePod. Does anyone have one of these in their house? OK, quite a number of folks. And just shout out, what do you use it for? What's the most common use case for these? OK, so I heard a bunch of different answers. The most common one I get in presentations is actually playing music, because it doubles as a speaker, a portable speaker in your house. I tried to use this for another use case, was as an alarm clock for my daughter to wake up for school. I don't recommend it. There's a fundamental flaw with chatbots as alarm clocks, which is when you say, Alexa, shut up, your alarm turns off. And that's what my daughter would say in the morning, and she would oversleep. So it didn't work out that great. Or maybe you're not even talking to a chatbot. Maybe a chatbot is talking to you. So this is some footage from Google Next conference.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have a 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
OK, so you can see we don't even have to write web applications and APIs for people anymore. We can just have the chatbots do it. This was a bit controversial when it was first released as a service. And One of the reasons is because, as you can see, all the pauses and the little accents make it hard to tell it's a robot. So one of the things they changed is that it announces itself as an automated robot before it starts an exchange with a real person. And it's quite useful for things like getting store hours or understanding different things which are hard to glean from online sources. So we can use robots to automate a lot of data collection. Or maybe you might see a chatbot like this. So this is a robot from a company called Aldebaran Robotics in France, who's the designer. They're now a division of SoftBank Robotics. They basically make robots which are entirely designed for human interaction. So they're used in fields like doing interactions with kids, with people in hospitals, with folks who have different challenges with communication. And one of the things you can use them for as well, so Pepper is the larger version, Now is the smaller version, and it's also a great way to teach kids programming. So one of the things I also do, and my daughter's picked up as well, she's now teaching kids programming, and it's a great way of interacting. So when you have a visual interaction with a robot, it creates that human-like interface, which really changes the way the kids engage and interact, and makes a great learning environment for getting kids involved in education. And this is one of the great ways we can also improve the gender divide in our industry, because at this age, all kids are interested in technology and are excited about it. And if we get them to grow up and are surrounded by technology, they're more likely to become the future set of programmers and developers in the world. Chatbots are great, and the great thing about robots in particular is when they fail, you can just have them dance.
Check this out. Dance with me. Okay. Well, let's go.
Okay, so the next technology we're going to talk about is serverless technology. It's not like this. You're not actually throwing away physical servers. What you're doing instead is we're using cloud computing, large sets of cloud infrastructure to allow you to run small micro functions on demand when you actually get requests in. So basically, rather than purchasing a lot of infrastructure and having running applications, just waiting there for a request, maybe a monolithic architecture, a lot of hardware which you have to spread out across the world. Instead, with serverless, you're using an existing infrastructure on a serverless cloud. You're paying by the server time used, use a microfunction architecture. And you get both scalability, but you also get the request time by the closest server to your end user. So it helps to reduce latency. In an ideal world, what you hope is you hope to get a graph like this, right? So as you scale up, you have perfectly linear scaling, and then you're not buying servers, so you're saving all this this time to actually purchase physical machines. And all that green is cost savings, right? Because you didn't have to buy all the infrastructure yourself. Now, as most presenters, if you see a graph, it's probably a lie, and this is very similar to that. And there's probably multiple things to this picture, but the most egregious one is I draw the slope of the line wrong. So the reality is that the incremental cost per additional function coming in is higher if you're using serverless technology. Even if the individual function cost seems low, you're typically going through an API gateway and other things, and that increases the price of the per transaction cost. So at large scale, you're probably not getting a cost advantage, but you are getting other benefits like the scalability, like uptime. You're leveraging existing infrastructure. You're not making capital purchases. So there are other advantages, and there's a lot of different options for implementing this. Kind of from left to right, I think you can see it's more proprietary to less proprietary. Amazon came first. Is anyone using Amazon Lambdas? Okay, quite a few folks. How about Google Cloud Functions? Okay. And finally, Azure. All right, so it seems like we have a pretty good spread of people using different serverless architectures. In the case of Microsoft, they've actually open sourced their whole implementation. So you can run it locally or you can run it in Docker images, so as an open source core. Google has an open source emulator. Amazon is slightly more proprietary, and the set of languages which they support also varies quite a bit. So they all basically support Node.js, Java, and Python. At the time I checked, it was in alpha and preview, but basically it's coming. .NET doesn't support, or rather Google Cloud Functions doesn't support .NET, so you can see a little rivalry in company technologies. Azure doesn't support Go. Again, Go is a Google language. And then Amazon supports Ruby. So there's a variety of different languages which are supported. But if you want more control over your serverless stack, another way of going is to use open source serverless frameworks. And the advantage with this is when you have an open source serverless framework, you can run it locally, you can run it in the cloud, you can create your own serverless cluster, and in a lot of cases, you can find companies which actually provide hosted infrastructure for these open source serverless frameworks. So some examples of this are the FN project, which was an acquisition by Oracle, OpenWhisk from IBM, OpenFAS, Kubeless, and the first two at least have large infrastructure provided by companies you can use for the serverless framework. And if you're using a serverless framework like this, one of the things you can take advantage of is owned serverless. So this is a phrase I'm coining. And basically, what you can do is you can use the cloud infrastructure to start with, to scale up, to do develop, dev, and test where it's relatively cheap. You don't have a large volume of transactions. And as you scale up, you can actually build out your own infrastructure and take advantage of economies of scale using technologies we're going to talk about, like containers, Kubernetes, etc. So, what are the top 5 reasons you might want to consider using serverless? So, number 1, your sysadmin quit. Number 2, you got 1 million free queries, maybe 2 million, and you have to use them all up. And after that, you're now a customer of one of our cloud friends. Number 3, you're already doing microservices and you want even more complexity. So this actually is one of the major issues with serverless frameworks is while serverless has a lot of advantages, it doesn't actually make up for poorly architected applications. So if you can't create a well-architected monolith, you also probably can't create a well-architected serverless framework for a large application. You have short memory and you like minimal state. And someone else is paying the bills and you just want to code. This is my favorite reason to adopt any new technology. It's good for my resume. It's a lot of fun to play with. And hopefully it's good for the project. OK, so we're going to chat a bit about container technology. So who's using containers already in your workflow? All right, so that's quite a lot of folks. This has really taken over in terms of a way of doing your development and test and even production deployments. And basically where we've come from is we've come from a world where we used to deploy things on bare metal. This actually is making a comeback, right? So high performance bare metal is a thing again. Then we started deploying things into virtual machines, and this gave us better hardware utilization. We could isolate things. We could run even different operating systems on the same machine. But then you had the disadvantage that the hypervisor and in general, all of the stuff in the middle would tend to slow down and reduce the resources that you have available on the machine. So it took an additional toll. But then containers came around, and this allows us to run with a lightweight container runtime, which makes it look like we're running in an isolated environment, but we're actually running in the host operating system. And then all of this is savings, right? So now we get this extra processing power, and extra speed back from the machine. And then we can take our applications and then package them up together, deploy a bunch of applications to the same machine, And we have a variety of different container runtimes that we can use. So who's using Docker in the audience? OK, almost everyone. Has anyone made the transition to Podman yet? OK, not many Podman people. This is another alternative from the CNCF. You can use it as an alternative to Docker together with Builder. Containerd is part of the runtime. Creo is used with Kubernetes, which we're going to talk about in a sec. If you want secure containers in production, you can use Kata containers, which gives a lot of the benefits of virtual machines to a Dockerized environment. And, well, one of these got archived by the CNCF, so RKT is no longer really being supported. So you pick your container runtime, and then you, of course, deploy it to your ship. Who likes my ship? Who's going to join me on my very seaworthy ship? OK, so a couple brave souls. Unfortunately, I think if we hit any icebergs, we're going to be in for a surprise. And probably when we get a production issue, we're not going to have a love story like the movie. So one way to go around this is to actually use Kubernetes to deploy to a large cluster of machines. And then we can have more resiliency in our network by having our application in a whole bunch of places at once. This gives us scalability. This gives us the ability to have fault tolerance, to do canary deployments and other DevOps techniques, as we're going to talk about it. And then we can play one of my favorite games as a kid. So anyone play Battleship? Oh, they're very good. Apparently, Battleship was not popular in India, where I was recently. And then you can go and you can sync different people's ships. And hopefully, when you're building out your cluster of machines and you're doing orchestration, it's nice and orderly like this. OK, so this is a busy harbor in Amsterdam, and you can see that they have wonderful orchestration in their ships. We would like to have that same beautiful orchestration of our services running in runtime. And to do that, we need a enabling methodology like DevOps. So I think DevOps can best be summarized with a cartoon. So thanks to Gregor Zimonski. Here is dev and ops. So we just throw it over the wall at ops. We get our agile delivery done, and then boom. Sorry, ops guys. How about DevOps? So now we're together, and it blows up on us. And finally, DevOps. So that dev and ops works together. We take it down on our customer. And we do like great large organizations do, and we test it on our end users. It's a very successful model. So there's actually a whole conference about DevOps coming up next week. Hopefully you guys are also going to be attending here. And one of my new colleagues, I just joined JFrog recently, Baruch Sadigursky, is going to be speaking there. And
I can speak now.
What?
Yeah, I mean, why not? I can speak now.
Wait. So do you actually know anything about DevOps?
Yeah, the tickets are on sale, by the way. That's why I'm here. Yeah, but everybody attended the keynote yesterday? Everybody know about DevOps. We can skip this part.
We can entirely skip
Yeah,
this
no,
part.
they know there are no such people as DevOps engineers. They know that this is actually a lie. They know that it's like agile, right? You know the things.
All right.
There you go.
All right. So they know all about this DevOps stuff already. And do they know what parts you were joking about and what parts you were serious about?
That's the hardest part in my talks.
Yeah,
No one knows.
yeah,
I don't know sometimes.
I think the people online didn't know that.
Yeah, no, that's for sure.
So the basic idea with DevOps is it's a process. I think in the words of Patrick Dubois, it's really about the methodology first, which came from Agile roots for how we enable this. But as good practitioners and geeks, we really care about the tooling, right?
Yeah, and generally, as we spoke yesterday, one of the implementation of DevOps is SRE, which is the reliability engineers, and they are actually developers who treat their infrastructure as it was a software problem, which means by code.
Yeah, I think that's a great way of looking at it. So there's different tools you can use to treat your infrastructure as code, to automate things, to use QA, to use different practices on it, to actually improve your development process and continuously improve it. And actually, there's another great example of creating things and turning them into code. And I'm gonna use this conference as an example of conferences.
Conference
as code.
Yeah, it's just the conference organizers hung up too much with developers, I guess. So that's kind of, oh, this is nice toys. Let's do conference by playing with those toys.
So you guys may not see this in the audience, but we got a behind the scenes tour, and we took a look at how all the great conference comes together. And JokerConf, in my opinion, I go to a lot of conferences, is one of the best organized conferences in the world.
For sure.
They actually have a lot of moving parts. So they have mixers. They actually have consoles, which are doing all the mixing of slides, mixing of speakers for mobile platforms, for YouTube. And they've even built their own rack system. So this has an audio mixer on top, but then it has systems for doing video switching, systems for taking HTTP video and removing the protection off of it. And all of this is very complicated stuff. And with anything that's complicated, you need software.
You need, we spoke about observability, here it is. This is actually Grafana, which is a dashboard for monitoring of software. Right, when you hook it up with containers, you can see how your containers are behaving. So this is a Grafana dashboard for monitoring the battery level in the microphone. So you can see here in the bottom a battery of 100% and 37% load. That's not me, that's someone quiet. But yeah, so this is really, really amazing how software for creating software and for DevOps is actually used for a conference.
Yeah, this is awesome. And a lot of this code, I think the organizers plan to open source. There might be other people who can find that it's useful. But getting back to DevOps, I think the same processes you want to have some sort of pipeline for stringing all this together. And this is kind of like what the continuous delivery pipeline looks for developers, right? So you're developing code, maybe in Git. You do agile methodologies, test-driven development, some sort of distributed version control maybe. Then you stick it to a build server, code formatting, automated tests, maybe use Jenkins, maybe use JFrog pipelines. Then you do your testing, functional tests, regression tests, integration tests, and finally you deploy it. So we talked about container technologies earlier. You might deploy it as a container to Docker or to Kubernetes or some other end server application, either on-premise or on a cloud environment.
Yeah, and there are a couple of pieces missing in the simplified picture. Like, for example, you need to make sure that you have security baked in, the DevSecOps, and someone already corrected me that the right pronounce is DevSecOps. I'm not sure, they are not pulling my hand. But yeah, so security and building pipelines on top of any kind of artifact repository, not implying any product here or anything. So yeah.
Yeah, so I think we've solved this problem. So now that we've automated all this, we don't need operations people anymore, right?
Oh yeah, no, we can fire all those sysadmins and DevOps engineers. We don't need them anymore.
We're done. So you should tell the folks at DevOps that.
Yeah, no, absolutely. That's what I'm.
Tell them all to go home. They don't have jobs anymore.
Yeah, no, I mean I have the opposite pitch, the keynote from yesterday. Yeah. I just reverse it, and then I will do a talk about how no one needs developers and
very good. So you do exactly the opposite pitch for those guys, and then they get rid of us.
Right.
But I mean, more realistically, this came up in the DevOps ecosystem. Was maybe we're transitioning to DevOps. So the role of a sysadmin or the role of somebody monitoring is really about making sure the code's deploying, your application's monitoring, your application is managing itself, and then doing all the automated patching. So your job as an operator or sysadmin hasn't disappeared. It's just that it's changed. The type of activities you're doing have changed in this new world.
And this is DevOps. This is something that a lot of people here heard about from our dear friends that we have a share of differences with Yegor Bugayenko, who was speaking, I think, last year about the importance of rigidness of pipelines, and how a well-defined pipeline that check all those boxes can actually improve the quality of the software because it minimizes the amount of bad software that gets into production. So yeah.
Okay, so the last thing we're going to talk about is a little bit about machine learning and AI. As we all know, this is the future, right? Because we're not, yeah. So the basic way which machine learning and AI works at a really high level is you're creating a system where you give a bunch of inputs into the system. Like this is like in the human sense, this would be our visual senses, like your vision or your hearing. You have a bunch of hidden layers which actually do the processing, and this is where all the magic happens. And then you have outputs out of the system where some determination's made, and you use reinforcement learning, or you train the model, or you have it compete against each other in simulations to improve the outcomes and try to get the machine to become smarter.
So it's basically a bunch of if-else.
Yeah, something like that.
Yeah, okay, yeah, that's what I expected.
So an example of a system which does this is with the DeepMind project at Google. They actually built a machine learning system which plays StarCraft, which is a real-time strategy game. So anyone here play StarCraft or RTS
Everybody played
games?
StarCraft.
Okay, you guys actually, you're showing you're a smart audience because a lot of hands raised, whereas I think other countries, they do all those FPS things where you just click on heads. That doesn't require nearly as much skill. But basically, it's large troop movement, war simulation type games. And you can see that the computer actually has a map that it's looking at. There's a representation of the hidden layers for what it's doing in the neural network activations. Then the outputs are considered locations, considered build train, and the outcome prediction of whether it thinks it's winning or losing. And what they did is they actually had AlphaStar compete in a AlphaStar tournament where a whole bunch of AlphaStars were competing against each other. They would then take the winners of those and have those compete against the winners of those. And they were able to run simulations which in human years would be thousands of years of gameplay in the matter of just a week of time for the computers to do that. And the computers actually got really good at StarCraft, where they were beating human opponents consistently. So they got some pro players from the pro scene, like Mana, to play against AlphaStar, and AlphaStar would win. And in particular, you saw that the place it was win, it didn't win in reaction speed because they throttled the number of actions, but it would win in outcome prediction. So AlphaStar would consistently make good decisions about when to engage or when to retreat, whereas us humans, we just overcommit.
Yep.
If you're losing, you're like, no, I'm going to try harder and then I'll win. It doesn't work that way.
And then you're done.
No.
Yeah.
So some examples of machine learning frameworks you might use. So TensorFlow, Caffe, Microsoft CNTK, MXNet, Torch, DL4j is a Java-based machine learning library, Chainer, Keras, Theano. And it seems like there's new machine learning frameworks and new systems cropping up daily. So obviously we're doing good jobs as software developers, creating lots and lots of different ways to solve the same problem. And we all know where this is headed, right?
Yeah, singularity.
So eventually the machines will get smarter than us. Their combined intelligence will exceed, definitely, it's already past Baruch and I. That's long gone.
Well, no, but that's a very, very, low bar.
And, at some point the machines get smarter than us. And so an interesting way of predicting this would be looking at a few conditions for when the singularity happens. So number one, you need a large set of data. So if you look at the data in the world, there's 7.2 billion humans, 6.2 billion nucleotides, and the digital world already has exceeded that. So back in 2014, we had 5 times 10 to the 21st bytes of data in the digital world. For the Earth, if we want to represent everything in the Earth, we'd need 1.325 times 10 to the 37th bytes, but we're going to get there pretty quick.
Yeah, that's pretty close.
Seagate's doing their job. They're cranking out more storage.
Yep.
Next thing we need is exponential rate of technology advancement. And so the latest Google tensor processing units, which do machine learning algorithms, they're version 3, does 100 petaflops. That's 10 times faster than the version 2, which I think was 12 petaflops. So you can do an enormous amount of processing in cloud-based environments for machine learning. And if that doesn't work, our friends at IBM are building quantum computers, and they're easily going to solve NP-complete problems and all sorts of crazy things with those. So the machines definitely have us up on intelligence. And then, finally, what the machines need is they need arms and legs, right?
Yeah.
So we now have machines. This is a 3D printer which can print itself.
That's useful.
So
This is how Skynet starts.
Yeah, exactly.
Yeah.
So basically, everything except the hot end, some of the wires, and the fan are entirely 3D printed. It snaps together, and it can print all the different components to recreate itself.
Yep.
So I think we all know where this is coming. We've seen this.
Yeah.
And it was all predicted in the 80s, and I think that this is how it's going to end up.
You saw it coming, right? That's like quite...
A weapon will be invented.
So this is because of Docker, by the way.
This weapon.
If you wonder what was the trigger,
versatile.
Docker.
And indestructible. It can't be reasoned with.
It can't be reasoned. Docker.
It will feel no pity, no remorse, no pain, no fear. It will have only one purpose: to return to the present and prevent the future. This weapon will be called the Terminator.
All right, so hopefully you guys learned a little bit about different technologies like serverless, blockchain, AI/ML, DevOps. I want to give a special thanks to my new colleague, Baruch Skadegurski, who is my co-conspirator on the DevOps Speakeasy, and for all of you and the great JokerConf conference. So thank you, guys.
Thank you.